Martin. Now I'm pleased to introduce our first presenter, Tim MW0RUD. He's first licensed in 2015, and Tim is a professional software engineer by trade, and so inevitably ends up writing radio-related software such as the firmware for the BATC Ryde ATV receiver, which is going to update us all on today, as well as share some of the future plans. And I'm pleased to tell you that, just like Martin said, you can ask questions or make comments at any time using either BATC messaging or YouTube chat during Tim's talk, and I'll read as many of them as I can to him after the presentation. Please include your first name and your call sign if you have one in every message. So now over to Tim. Welcome to CAT23, Tim.
Thank you, David. Yes, so I'm going to talk about the Ryde. Inevitably, I end up, as David said, I ended up writing the software. Also, I inevitably end up doing more writing of the software than I do of using it. I do a lot of the satellite operating, receiving with it. But yes, I will quick introduction to what we're going to talk about. So I'm going to give a quick introduction to what the Ryde is for anyone who's new. And then I'm going to talk about some things since I gave a talk 2 years ago, new things that have been introduced since then. And then what the kind of things that are coming up down the line. There's always new features to add. And then going to give a bit more further explanation on some of the features in the config file, because that seems to be something that people always need a little assistance with. So, what is the Ryde? It's designed to be a set-top box, but it will do the narrowband modes that we use as amateur radio, that more efficient into the bandwidth. That are technically outside of the spec, so off-the-shelf receivers won't do it. It also has a wider tuning range. It uses all the features of the mini tuner. It also has quick access to things that are more difficult with a traditional set-top box, such as the frequency and bandwidth. Normally they're buried away in a menu or even completely inaccessible, and you have to scan for channels. So at the moment, you can access them from the menus very quickly. And all of these other things, when we get to make our own software, the changes that we'd make compared to a normal receiver. It's built with a Raspberry Pi and a BATC tuner, as you can see in the picture. Yes, it's designed to be very easy to use. You don't need a computer. Certainly once it's set up, you can use it entirely without a computer. You can buy a SD card from the BATC shop and put it into a Raspberry Pi, plug it into a mini tuner, and there are some defaults. For setting up your own infrared remotes, you probably will need a little bit of assistance from a computer, but that is only for the setup. Once you've got that configured, you then won't need a computer. So finding someone to help you with that is, if you're struggling, is not an ongoing task. It's used for a lot of repeater inputs, because again, it's just HDMI output or a composite output. So it can go straight into any repeater. And as I said, it works on all these the narrower bandwidth, so it's been quite popular. Lots of people also have them for shack displays and satellite receivers for things like QO100. Yeah, so that's the basics of what it is. So since 2 years ago, we added some new features. Some of these were coming down the line. Some of these are completely new for a while. The RTMP stream, so BATC streamer receiver, again useful for repeater inputs. People who have receivers, people who have stream receivers. It reasonably reliably receives it and outputs the same things like a lock signal, which is useful for repeaters. I think some people do watch nets and things on them as well. To combat some issues we've had with things crashing or hardware problems, I've created a pair of watchdogs. So there's an internal watchdog that if there's things like hardware failure, your mini tuner gets disconnected or loses power or something, it's now capable of watching for that, and it will recover automatically. Well, if you reconnect it or fix the problem, or occasionally we get strange RF events that will cause some of the internals to crash, or Longmind, for example, can crash under certain strange events, and Ryde now keeps an eye on this and will restart these things if they fail. There's also an external watchdog that it will service. So periodically the Ryde software leaves a note to say, hey, I'm still here, I'm still working. And then there's an external piece of software that Dave has made that just watches for these little updates. And if it hasn't heard one for a while, it means that the Ryde has crashed or it's locked up. And then the external software can restart it. Occasionally we find odd bugs or strange environments that have caused crashes, and we've added these features to make it a bit more resilient for unattended viewing again. Things like repeater receivers or demonstration stations. For example, there is now a demonstration station at the RSGB National Radio Centre at Bletchley, and they've had some issues, some of which to do with the interactivity they're adding. A much requested feature that I've had since it first came out has been longer menus. We've had problems with there being more people wanting more presets than will fit on the screen. So I had some design issues and some slight technical flow issues to solve to get this working, but now I can say that you can have as many presets as you like. Obviously, if you have a lot, you're going to be forever scrolling through the menu, but now it will expand the menu up to fill the screen, and then if you add even more, it will scroll, so you can have a lot of presets, which now makes it much easier to navigate, as before they would go off the bottom of the screen and you were trying to navigate the presets blind by counting how many button pushes you had to do. Again, yeah, that's very popular, requested. Another feature we've had, the way that features get prioritized, it's to do with kind of use cases. So lots of people ask for scrollable menus, but people like repeaters, keepers, and engineers asked for some ability to display things on the screen. Some custom text for things like call signs or repeater receiver identification. So there's this player ID. It will automatically generate a player ID if you don't specify it in the config file. I'll give a bit demo of that later. The player ID will display on screen, so you can add some custom text to the screen, particularly useful for repeater receivers, or if you have multiple receivers, so it's a bit easy to keep track of which receiver is what. So if you have a stream receiver and a satellite receiver showing you the same thing, it's a bit harder to get lost if it tells you on the screen what you're looking at. And inevitably, the other thing that's always been going on is there's always small fixes, people finding bugs, little tweaks to things. There's always a fair amount of new things coming down, or like hardware changes. Okay, so that's where we've been, and this is where we're going. Now, I've included Raspberry Pi support as an upcoming feature. My Raspberry Pi 5 has not arrived yet. Hopefully it'll come in the next week. I'm not promising anything on timing because there's a lot of unknowns. I've got my fingers crossed that it'll just work, but I've got some concerns that I might need to do some not insignificant development. It depends how much things they've changed, but we'll find that out when it arrives. There is no need to worry about getting a Raspberry Pi 5 at the moment. They're quite hard to, they're all back-ordered till next year at the moment. But a Raspberry Pi 4 does just fine. You don't need to worry about it. It's just that for some potential future software upgrades, we may be able to benefit from some of the improved speed of it. You might get a slight power saving if you use it, because they say that it will use less power for the same workload. Obviously, our standard workloads aren't changing. There's various things to do with the transport stream encoding that need to be upgraded. We have to handle. At the moment, there's some problems with things like multiple streams, so with transport streams with multiple programs in it, but also the way that the data flows through the software currently causes some issues to do with adding future features. So I need to add do some behind the scenes work on some transport stream handling capabilities, which will then make it easier to do other things with the data input. For example, the recording and streaming. So this is input recording and streaming. There's no re-encoding. So this is designed for recording the input TS, and it will separate these things out, separate them out by signal. So if the signal goes away and then comes back, it ends up in a different file. But this is raw, so this is designed, and it splits the files out so that if there's codec changes, if you're recording a net or something, it will split them out for easier re-encoding. But this is the raw stream. This isn't for streaming out. Again, with streaming, it's not for streaming to the BATC streamer or anywhere. It is for streaming out to an application designed to receive it. It is the raw input. So things like the transport stream merge for the International Space Station, that requires a raw stream for the transport stream to go out. And that, so we'll want to add the ability to do that, ready for when that is back on orbit and receiving, so that people can view it on their ride and stream it out and record it at the same time. So other upcoming features. Now, I've been doing some initial research into SDR support. This probably is going to require the Raspberry Pi 5, and it's probably going to come in several stages. Probably there's going to be an initial SDR support, so you can use probably two SDRs, because they're the ones I have, and it's probably not it won't be as sensitive as a mini tuner. So it's not a replacement for the mini tuner at the moment. It's more of a development platform for people, because there's some improvements that need to be done to the SDR software chains that are pre-existing. So they're going to need further work. So if I can provide a platform for that, it will make it easier for everyone else to make improvements. But yes, as I said, Raspberry Pi 5, because it is very computationally intensive. But we'll see how the Raspberry Pi 5 does when these things come. So yes, hopefully we can get a development platform that is worth it, and then people can make some improvements, because at the moment the sensitivity is not good. It's about 2 dBs difference between a mini tuner and an SDR. So definitely some software. I've said this before about upcoming things. The on-screen config, that I think I've mentioned this several times in several talks, that is upcoming. There's lots of things keep getting in front of it. Lots of changes, lots of whether it's work steals time from developing Ryde, or whether it's new Ryde features that need to be built ahead of it. But yes, the idea is that there's an on-screen config, and the on-screen config will will make the necessity at the moment of the console menu. It will reduce that necessity. But first, I have to have it so that any config file that you pass into it, it can pass out of it, and it be the same. And then I can start building user interface components to let you modify things, probably presets and patterns first. So we'll see how that goes. Again, it's reasonably low down the list in terms of upcoming features, but it is an important one. It really will reduce the necessity to have an external computer for the setup, and will reduce some of the limitations we currently have using the console menu to write the config file. There's potentially some small UI improvements and other things coming down the line, and inevitably new and exciting features that I haven't thought of yet. There is always the potential for new features. A good way to get, if you've got a feature that's upcoming that you think is missing, as with all volunteer-driven software, the way to get it done is to get the person writing the software excited about it. That's how the priority works. If I'm excited about the use cases or the feature itself, or it sounds like an interesting technical challenge, do file an issue. So yes, there's always these. There's always options to things, and skip the menu, skip the queue. So like Raspberry Pi support suddenly skipped up the menu. Raspberry Pi 5 support skipped up the list when it was announced, because I thought, oh, that sounds like an interesting thing I should probably check. And the hardware looked interesting. So now some quick thanks before we get on to talking about the some config file things. Obligatory thanks, particularly to Dave. He does all the build managing, and he manages the database of handsets. He does all the alpha testing, and is generally very useful for things. Heather, who wrote Longmind, and Phil, who's been doing a lot of the maintenance and little feature adds and adjustments. And Charles, who wrote the Knucker support. And of course, thanks to all the testers who point out things that are broken, or something's changed, or I've broken one thing while fixing another thing. There's always bugs, always a thing to chase, and if it's a feature that I don't personally use particularly often, then obviously the people who do use it will notice and let me know, and I can sort it out. So that's kind of an introduction to where we are and an update. So now I'm going to give some more information on the config files, as they are a continuous, periodically get people who are having trouble trying to make modifications, or people who say, oh, can it do this? And it's like, yes, but you have to edit the config file for it. Again, some of the on-screen configuration features later will hopefully make some of these more obvious, but for the moment you've got a config file to manage. It's mostly managed by the console menu at the moment, for setting your presets and your bands and various other settings. Updates, if you've made custom changes, occasionally we have to reset you to the default config when there's updates, because things have changed. Also, if you make manual changes, then the console menu will tend to override them. So the files itself, I'll show you an example in a couple of minutes. The files themselves are YAML files, which is a standard format. It's this hierarchical indented file format. It's indented with 4 spaces, specifically 4 spaces. We've had various problems with which I suspect have stemmed from people using tabs or the wrong number of spaces. Every indentation level is 4 spaces. The easiest way to edit it and to maintain a valid file is to edit it on a computer and then check it with a validator. There are various validators on the internet. So what I recommend you do is you copy the file to your computer with any SFTP file transfer, particularly SFTP or SCP. There's a few different names for the things it supports. It doesn't support standard FTP, but yeah, you should be able to find an application, find a recommendation for a way to get that file onto your computer. I would then recommend you make a copy of it, so that if there's something goes wrong with your editing, you can put back the previous version. Always do your backups. And then you can open it up. if you open it up in any text editor, if you open it up in a slightly smarter editor, things like Notepad++, something that will assist you with the indenting, it will be a bit more likely to get the indenting right. And you make your changes. I'll go through a list of various things you can change in a minute. And then you can run through an online validator. YAMLlint.com is an example. There's lots of other examples of validators. There's lots out there. They do different levels of validation or cleaning and tidying for you. That will then would check the file for YAML valid, which means that the Ryde will then accept the file and attempt to interpret it. If you've made certain kinds of mistakes, from then on, generally it will import everything that is valid. So if you've made a typo, it will import all the things that don't have a typo in them. So if you've renamed one of the sections by mistake, for example, then it will potentially not load that section, but it will load all the other sections. So if you're editing the on-screen display, and you make a mistake and that section is invalid, it will hopefully still load all the bands and the presets. There was a complete list. It's now getting quite a long list of what is in the config file and a full description of all the settings on the GitHub at the link that's on the screen. We also have, I'm going to go through them in a minute, go through some of the sections and give some examples. So generally the file contains these are the primary sections. The default file has 234 lines, I think, and the sample file that I provide, which is different, is 266 lines. The default file is a good example of all the settings, as well as being a good place to start. And we provide it by default. It's got a lot of good presets, sensible presets in there. The sample file that is provided with Ryde software specifically is designed to be a sample of demonstrating things you can do. It is not designed to actually be used. It's more like, I'm not sure how to do this slightly unusual feature or this setting, and the sample file there, we've generally got examples, so it does some very odd things, and it's not generally the file you want to be running. Okay, so these are the broad sections. So config revision is mostly an internal setting. It's there for me detecting when I've had to make structural changes to the file. Generally, you should leave it alone. I think the current value is 3. Player ID, I'll go into more detail in a minute, but that's the player ID idea I mentioned for drawing some on-screen stuff. Sources are things like Longmint and Combi Tuner. It is the global settings for like the mini tuners, global settings that will apply to all bands and all presets. Bands, they're designed to be signal flows. So anything that's got the same IF and comes in through the same route into the Ryde will be all in the same band. So that if you're tuning your LNB offset, for example, then you only have to tune it in one place and it will apply to all presets that use that band. Presets are what they sound like. It is a set of symbol rates and frequencies, for example, or various other things that are a specific channel for receiving specific data. The default is usually a reference to all of the presets of where you want what channel you want to come on when Ryde starts. There's an infrared section that is all about setting up your infrared remotes. Some of these, I'll go into some of these more technical settings for that in a minute. GPIO is the same. It's for the button board, for any buttons you've got, or other GPIO settings like the band output settings and the lock light. OSD is for all the on-screen display settings. I'll give a few examples of that in a minute. Network, you generally want to leave alone. In there, it's to do with like the bind port for the network API, but it's settings that you might have to change if you're doing particularly technical things or you have conflicts. But generally, you need to leave those alone. The watchdog and the watchdog service. So the watchdog is the internal watchdog to do with monitoring things like longmin, and watchdog service section is to do with the external watchdog, about where it writes its tracking file. Shutdown behavior is all to do with what happens when you push a power button. To do with, do you shut down the ride, do you just close the software, do you reboot, what the defaults are. Audio is mostly things like volume control of default volumes, mute, not mute, as well as whether you want to enable the volume menu. The volume menu is only really useful at the moment if you don't have direct volume control buttons on your remote control. Then you can use the volume menu to adjust the volume on the fly, rather than having to edit the config file and then restart it, or have multiple roads or something complicated. And then there's a debug menu. Generally, you want to keep out of the turn the debug menu, leave the debug menu off, and there's a few settings in there. Generally, we leave them at the defaults. It's things like, therefore, debugging. We might ask, if you're helping us solve a problem, we might ask you to change some of the settings in there to try some different options. There's things like a different text rendering that supports emojis, but has other disadvantages, and it causes the Ryde to crash periodically. So you can turn that on and off. But we kind of introduced some of these prototype features in there. Okay, so this is what the default config looks like. It's very long. This is the sample config. Sorry. Yes, it's designed to show off what's possible. Yes, you can see there's a config revision 3. I know it's very small, but yes, it shows you quite how long it is, but does give a decent demonstration of what's in there. Just as an example. Okay, so now I'm going to go on to some examples of specific changes you could make depending on your specific use cases. So, for example, this is quite an old screenshot now. I think I've shown this example before. So the on-screen display has 3 sections. You've got one to do with timers, and then an active and an inactive. So when you push select or the on-screen display on a dedicated on-screen display button, it brings the on-screen display becomes active and then will deactivate according to the timers. Also, the program stream, like the transport stream, if the new signal comes up, it will automatically activate it, and the timers at the top are to do with the triggers for that. I think I'll go into a bit more detail on the next slide. But if you just want the signal level to be there all the time, you just need to add it to the inactive section. So you see here, I've taken the signal level, and it's both in active and inactive. If you moved it instead of copying it, it would then disappear when you activated it. The null, I'll talk about in a second. Essentially, it means leave it in the default location. So yes, this brings us the MER up and leaves it up all the time. So some other kinds of changes you might want to make is, for example, this. I use this when I'm aligning my dish. So I go in and I adjust the user trigger, which is when you push select. If you set it to null, it will never time out. You can push back to get rid of it, but it won't time out on its own. If you set it to 0, it'll never come up. You probably only want that for the program trigger. So these are the timers in seconds on these lines. So the program trigger, if you set it to 0, when the signal changes, it won't pop the on-screen display up. So in this example, the rest of this example, I have deleted a lot of the other on-screen display sections, and I have moved and resized the signal level, which is what you want for aligning a dish. And I've just made it as big as possible. So the way that this works is you replace the null with a subsection that's got these five fields in it. So datum tells you what the reference is. So for example, the center, CC is center. So it will align the center of the center of the screen and the center of the on-screen display module you're talking about. And then any XY offset is relative to the centers of the two things. Excuse me. But the top left, you can do top left, top center, top right. A lot of the default, there's a lot of modules that are all related to the top right, and then some in the top left, and the bottom center is where like the program box displays that tells you like, the channel you're tuned to and the received information, whereas all the signals, a lot of the signals are connected to the top right. So yes, you can all four corners, all four edges, and the center of the screen. So, and it's all, and then your XY is if you want to move it. So if you're referring to a corner, you can then push it out from the corner a little bit, or push it down from the top. Using XY, these are all fractions of the screen. So 0 is the same place, 1 is a complete screen across. So that you'll find small numbers in the default configuration. Width and height are the same relative to the screen. So width says 100% width, width 1 says 100% width, height 1 says 100% height for the module's box. And then it will try and draw all the settings within that box. Draw the relevant module within the box that you define. So in this case, I've got a module in the middle with 100% width, 100% height. So I've got this big MER display in the middle of the screen. The other thing, this is one of the new ones, is the player ID. Player ID is auto-generated, but you can also specify it. For example, in this example, I've got dev player set, but you might have that this is a stream receiver input. So you specify that at the top of the config file, just below the config revision, and then you have to make sure you add the player ID module to your active or inactive or wherever you want to display it settings. It follows all the same alignment settings, and you just get a little bit of text. So as you can specify that text, yeah, you can make it say whatever you like, but you can also move it around and resize it as necessary. Using the settings I showed you on the previous slide. So if you want to make it bigger, if you want to make it more obvious, put it in the middle of the screen, I don't know. It's just a little bit of text you can add. By default, yes, there's an auto-generated setting based on the serial number of your Raspberry Pi. So if you have multiple Pis with the same config, they will have different player IDs. So that's most of the on-screen config setup. Now, one of the other things when I was talking to people last weekend, people were saying they had problems with debounce on their buttons and on their remote controls. So that's, you push the button and you get two pushes. Like if you're scrolling through a menu, it jumps 2 settings. Or if you're pushing the like an on-screen display button, it kind of pops up and goes away again because it thinks you pushed it twice. So there's some settings to do with debouncing. So I've drawn a little diagram. I don't know if you can read it. You can probably, if you have you might need to make the screen a bit bigger, watch the video back later. So there's 3 settings in here designed to reduce accidental repeated inputs. And I think the defaults are probably too short, and we can look at changing them. That work for both the infrared and the GPIO. So I've done this example. So the big thick black horizontal line is when you're pushing the button, and the little vertical arrows are when the events will go off. So, and then the little horizontal arrows are examples of the individual timers. So repeat first is the time between the first instance and event and when it starts to rapidly repeat. So when you push the button, it will wait this long, currently set at 200 milliseconds. by default. We should increase this to reduce some of these issues, and then if you keep holding the button, it will then repeat at repeat delay. So every 100 milliseconds, so 10 times a second, it will push the button. So as you see, there's a big gap before the first one, and then it repeats. And then there's the reset delay, which is how long do you have to let go of the button before you then it will do the repeat first again. So the repeat first section, so any gap under 400 milliseconds in the default, it will ignore. This is to do with the way some infrared remotes work. They don't tell you when you push the button and when you let go. They just keep sending the signal repeatedly. So we need ways to tell the difference between these things. So the first red section, when you're not pushing the button, it won't necessarily detect it. So if you let go and push it down again, that timer hasn't expired, and it will keep repeating at the high rate. Whereas after the second gap, the green gap, it will then wait that longer first repeat time before going into the rapid repeat. So yes, I think we need to do some tuning with this. These settings were back of the envelope, I was just playing around with them. Playing around with the settings kind of worked in my test setup, and we've not really revisited it, so potentially these should be extended, because 10 times a second repeat and only 200 milliseconds between the first and the repeats, definitely a bit short, particularly because of the way it works. If there's some lag in the software, it will then, if there's lag in the software, it will, because it's to do with when it processes the event and not to do with necessarily when the event happened. If you have a lag, it will potentially be quite a long time, and you will get the multiples because it thinks you've pushed it several times. There's a few instances where I'm still looking at reducing some of the lag in the software, but things like when you change sources, so if you go from a stream receiver to something that's receiving on mini tuner or vice versa, there tends to be more time while it resets some of the internals, and it causes a little bit of lag, and you might have some problems navigating. But yes, if we increase these, feel free to go and increase these times. Be interested if anybody finds a good balance that's not too slow, but has a lot less bouncing issues. I think that's probably everything. So now I think we're gonna hand back to Dave to see if we've got any questions.
Thanks very much, Tim. It always amazes me how much work goes into something like this. I'm afraid I'm an old-fashioned chips and solder man, really, and so code had sort of kind of left me behind. But it's incredible the work that you put into to make this stuff, and how flexible, of course, that makes the design. So thank you for the presentation. Thanks for all your work, of course, on this as well. And this is a great time now for you at home, if you haven't already done so, to ask a question or make any comments for Tim. Any questions on Ryde or any aspect of it? As you probably know, later on in the day, Dave is going to talk about the specific problems of the tuner, which we've got to replace. But other issues at all, the software, maybe a wish list. Tim, if you still have some, if you're still open for some ideas and things. So let's have a look. I don't think we've got much at the moment, but actually saying that, I've got John.au says, thank you, Tim, for the fantastic Ryde. Is there any possibility for the Ryde, in addition to RTMP stream receiver, to support SRT? We would love to use the Ryde and SRT in our repeater installations.
I'm not entirely sure what SRT is. We have I have looked at adding some more video stream codecs. For example, the RTP and RTSP settings, but they're quite involved. If there's a specific one that you're looking for, go and find the issue tracker and file an issue, and then I can have a look, and that's a good place to go and thing. It's on the GitHub. It should be linked. There should be links to it around. But yeah, go and find it if you've got specific hardware software requirements or something. Particularly, like I'm keen for repeater inputs. I'm a bit more willing to put in a bit of effort if it's going to assist multiple people. So yeah, please go and find the issue tracker on the GitHub and file an issue for that one, and I will have a look at the details about how complicated it is. Potentially, it might be quite easy, but some of them, like as I said, the RTSP I recently looked into, and it requires a reasonably extensive amount of work to get that working. So it's not particularly high on the list.
Okay, John, remember Tim's great tip earlier on. You've got to excite the programmer if you want him to do it. So hope that helps, John, anyway. So if you can add any more details on your question if you want now that I can read back to Tim, but best to put it on the GitHub as he suggested. Now from Mike G0MJW, he said, here's a general question. How about a Ryde running on an old PC? What are the challenges?
So the Ryde is very specifically designed for the Raspberry Pi hardware. Some of a lot of the video stuff uses the Raspberry Pi's GPU to do the compositing. So at the moment, that is probably one of the primary things that would stop it running on anything other than a Raspberry Pi, because it needs these GPU functions. Again, potentially I could composite in software or in a more generic fashion for doing it, but yes, it's built out of layers. The Raspberry Pi's GPU currently does all the layer compositing, so drawing all the things over the video, for example, the video is on one GPU layer and the menu is on a different one and the on-screen display is on a third. So all of this compositing and this layering is done by the GPU, which helps with the performance of the Ryde. There's a few other things, like obviously you don't have GPIO on a computer. But yeah, potentially in the future I could make some of these modifications so it was less dependent on the Raspberry Pi hardware. But yeah, then it would run on any Linux computer probably.
Okay, thank you. Yeah, Mike has just come back and actually said, thanks, Tim. This is less relevant now that Pi 4s are available again. Of course, there was a huge shortage, wasn't there? I think they're pretty freely available now, though I guess a lot of people might be putting that off for the Raspberry Pi 5. You talked about generally it's next year, is it? I did see the adverts come. I thought, well, I haven't done much with my Pi 4 yet. I better not order a Pi 5. But they're sort of, so we're into availability early next year for Pi 5s?
Yes, I think for new orders, I think it's going to be next year for the Pi 5 now. Possibly a little earlier, late December. But yeah, the pre-orders, I think the pre-order times are currently about there. I ordered mine on release day because I knew people would ask the questions, and for development. So I've ordered mine, so mine should be in the first batch. But yeah, I think we're into batch 3, which is early next year now for most of them. There might be some slightly better availability on the 4GB version than the 8GB version. You might get them in the earlier batch, but yeah, generally places seem to have first batch is sold out, which is the one that's supposed to be next week. Second batch, I think, is late November, early December, and then the third batch is early next year.
Okay, thanks very much, Tim. Actually, related to the Raspberry Pi 5, Phil G8XTW says, with no audio out on the Pi 5, just embedded on HDMI, what are your thoughts on this?
So generally, I would recommend using HDMI displays anyway. But one of my test setups here is an HDMI to composite converter plugged into the HDMI on the Ryde that then will output the composite and the audio on the 3 plugs. So you can still do that with the HDMI. There was also the potential for you could plug in a USB sound card, and then we've done it before. The change you have to make if you've got HDMI output and analog audio, you've had to make some changes. You probably have to do something similar to get that working. But again, some of these things don't quite know what the best way to do it is, and we'll see when I get my hands on a Pi 5 and see how it reacts. There's a lot of kind of unknowns about exactly what changes they've made. But yes, apparently there is technically audio on the board somewhere. It's just not on pins you can get to. So we'll have to see if anyone finds that. There's potential also for audio out via the GPIO pins, but I think we're probably using the necessary pins for other things. But yeah,
I doubt they changed the
questions for next week.
Yeah, absolutely. I doubt they changed the format of the IOs and things at this stage, because they want things to be backwards compatible as much as possible. But anyway, as you say, we won't put you under pressure that. We'll wait until you get yours, and then I'm sure you'll let the community know as soon as you can. John, by the way, John -AU, possibly from Australia, I guess, says SRT is another protocol, another library addition to FFmpeg. So that's what it is. But hopefully, John, you'll put this onto the GitHub as Tim suggested. Okay, we haven't got any other questions, I think, at the moment. We've got several people watching from all over the world. We've got Paul OE8 PCK watching on holiday in Budapest. So I don't know what the weather's like where you are, Paul, but hopefully it's a little bit drier than it has been in the UK. I think most people have had some rain. Nothing else particular, I think, to mention at the moment. So I think that's probably it for now. Tim, thank you ever so much, as I said earlier, both for your presentation, but even more importantly, all the work that you put in, the dedication that you put in for this to support the community. I've got one question, if that's all right, just to finish on. And the ride itself, do you see that this is going to be a continually evolving project, or are there times when you sit back and think, if I had my time again, clean sheet type design? What do you think?
Yeah, I think we can keep going. It's all open source, so even if other people can assist, I will accept code changes. But yeah, I think as Dave's got to talk later about the potential problems with the mini tuner and potential replacements and issues. So as we've seen with other things, as new hardware comes out, it's built in a way that's reasonably modular. It's designed to make adding new hardware support reasonably easy. So yeah, as new hardware comes out, I have to kind of keep up. But hopefully we can keep going. There's a long list of things. As people will tell you, software is a never-ending thing to chase. There's always new features to add. People come up with new features or new hardware, or things change, and you're always chasing it.
Great. But so you're still encouraging people to send in ideas as well.
Yes. Yes. Always look for ideas of new, interesting things to write, because I enjoy writing software. I enjoy the challenges that it comes with, and it's a good excuse, and it's better than writing kind of toys for myself that make something useful for other people. And for people like yourself, like you said, you're more kind of a solder and building the hardware person. So if I can write the software, you can then build the hardware, and you don't have to worry about it, and still get the project.
Absolutely. Well, thanks ever so much. Your enthusiasm is infectious, and we're really grateful to you, all the work that you've done. Thanks ever so much for joining us today, Tim.
Thank you, David.
Thank you.